Today, for our flat earth silliness, we will take a look at flat earther Kyle Adams and his flat earth science lesson on Australian plane flights. Now, isn't that an oxymoron? Yes, this is a debunking video and I am biased. But in all fairness, I think it is a very smart video. In fact, I actually agree with the first half. Shocking. Well, before we jump into the actual video, there is something else I would like to touch on. None of us are infallible. We all make mistakes, we have done it before, and we will do it in future. We just try our best not to. Heck, even Sir Newton thought he could turn lead into gold and believed in God. I'm saying it now as we will be revisiting this shortly. I'll summarize the video. Link to the original video will be in description, so you can confirm that I haven't taken anything out of context. The main point they make, and which I completely agree with, that you cannot measure the distance between places using flight time. To prove that fact, they showed several flight plans, one from Perth to Brisbane and another one from Melbourne to Townsville in Australia. Though one can argue about error margin, JetStream and such. Then they use two drive routes to illustrate the same point. Hey wait, car don't use JetStream? So far so good. Now they point out,
many globe earthers claim that you can verify the accuracy of a map by measuring the flight duration of planes.
The incredibly snarky Professor Dave alluded to this in his 10 challenges for flat earthers.
Number 9. Take some flights, like any direct flight in the southern hemisphere. Whoops, shouldn't that be impossible? Better yet, fly between two cities 2 different ways. The shortest way on the globe and the shortest way on the flat earth. Which one do you think will be faster?
And oh look, here is an anti-flat earth meme, where a globe earther is trying to verify the accuracy of a map through the duration of plane flights.
Well, I can't comment on many globe earthers claiming that one can verify the accuracy of a map using flight times. If there are any, they are wrong. Sorry. But I will argue the snippet you have used of Professor Dave. You did say that he alluded to such, but on his example, he pointed out flight time taken between the same 2 points on both globe and flat earth. My interpretation was that he was pointing out the ridiculousness of flat earth model, showing distance between Australia and South America. Same with the meme. It's showing how the flight time fits better with globe model and not really measuring distance. Well, first what I have experienced. I had been working in Riga for about 10 years, flying there and back almost monthly. At some time of the year, it would take me a lot less flight time to get to Riga from Leeds Bradford than coming back. Other times of the year, they would be almost same, and yet different to winter times. This is down to the JetStream that influenced the flight plan during particular time of the year and allowed tailwind help me get to Riga quicker. Good old days. To be fair, they looked at the return time from Brisbane to Perth and confirmed the time difference. Keeping that in mind, is there anything we can do to minimize the error? Well, how about we add both direction time and average it? Then if we can do the same over a year, we should have a pretty consistent values, right? Which means, even if one particular leg, that flying is getting a serious tailwind, well, our average would cancel it out, taking the headwind into calculation. The meme showed us 3 places. Let's try them, shall we? Leg 1 is Perth, Dubai. Leg 2 is Dubai to Johannesburg. And finally, leg 3 is Johannesburg to Perth. This is where I ran to my first hurdle. Due to the pandemic, a lot of flights are not operational. In fact, I can find no direct flight for Johannesburg to Perth, and that was the first I was searching for. No problem. Maybe I can find some historical records. Well, there are some sites with limited data, but nothing for free. I can fly that route on Flight Simulator, but that would be over 29 hours of my life that I would never get back. And 2 of those legs are boring as heck. Well, without all those data, let's do some calculation just based on scale and assume we have an aircraft that can do crazy speed at legs. First, on our globe model, I have used Google Earth to get me the distance between those 3 points. On first leg, Perth to Dubai is 9,026 km. Second leg, Dubai to Johannesburg, is 6,390 km. And finally, leg 3, Johannesburg to Perth, is 8,326 km. Next is to do the same on a flat Earth model. I started with the highest quality image I could find, and it's not that high quality. I also got some flat Earth JetStream just for giggles. I have drawn the same flight path in that model. Leg 1 is 605.71 pixel, leg 2 is 356.89 pixel, leg 3 is 924.62 pixel. Obviously, it goes without saying that these are estimates. I mean, how to point Dubai on a flat Earth from a real location? That map doesn't even make sense. On screen, you can see a table with 3 legs with distance from Google Earth, from Flight Earth model with flight times. We have calculated our estimated flight time with a constant speed of 820 km per hour. So yes, I know, takeoff, climbing, descending and landing speed are all the same as cruising speed. Please note the difference between recorded flight time and our calculated time, knowing that we didn't take any other factors into account. So we have an error margin of minus 3.7% to 5.2% from recorded flight time with our chosen speed of 820 km per hour. When it comes to the flat Earth model, we have some issues. As you can see from Globe Earth, leg 1 Perth to Dubai is longer than leg 3 Johannesburg to Perth. But on the flat Earth model, leg 3 is almost 1.5 times longer. I thought it would be fairer to average out 3 distances from flat Earth to Globe Earth, which gave me a 12.58 km per pixel value. With that, we can convert my flat Earth pixel value to kilometer distance and then to estimated flight time. Again, without any other factors, compared to known recorded flight time, we have an error margin of minus 32.3% to 47.48%. For those keeping track at home, our simple calculation ignoring variables like JetStream, on a globe model, our error margin is between minus 3.7% to 5.2%, whereas on a flat model, that error margin jumps to 32.3% to 47.48%. That's not all. Those sharp-eyed would have noticed my final row, required speed on flat Earth. So given we know the flight time, and assuming given values have taken average into consideration, and we know the leg distance on flat Earth, what is the average speed? Well, on leg 1, from Perth to Dubai, the aircraft has to fly at 697.9 km per hour. On the second leg, Dubai to Johannesburg, it has to fly 555.34 km per hour. And on the third leg, Johannesburg to Perth, it has to fly at 1209.4 km per hour. On the second half of the video, it talks about how some of us Globers have refused to accept that JetStream can increase aircraft speed and can even cause it to go faster than sound. Well, speed of sound is 1235 km per hour, while a typical commercial aircraft cruising speed of 926 km per hour. JetStreams can reach up to speed of 442 km per hour. As I have mentioned this on one of my previous videos, unless the flight departure was delayed, a commercial flight pilot facing such tailwind would save on fuel and reduce the speed. But if they still flew at standard cruising speed, that would bring them to 1368 km per hour and faster than speed of sound. So I am sorry on behalf of those morons, if there are any, who refuses this fact. More on this later. Before we look at JetStream on a flat Earth, let's see those numbers again. For simplicity's sake, let's say the final speed is aircraft speed taken the JetStream speed into account. So when the craft is flying the same direction, it basically gets added. And when it is flowing against the stream, it is a subtraction. On leg 3, the craft has to reach an average of 1209 km per hour. Obviously, if the tailwind or JetStream speed is higher than flight speed, that aircraft can never make the reverse trip. For argument's sake, let's start with a 60-40 ratio. So JetStream is 40% of the total speed, which means the reverse trip, the aircraft, would have a speed of 241 km per hour, meaning instead of 577 minutes, it would take over 48 hours. Oh dear. If we move to something like 90-10 ratio, that means our aircraft is flying at 967 km per hour, meaning it would take over 12 hours or 2.4 hours longer than recorded time. But if the airliner is flying at that speed on that leg, what is their motivation for flying at lower speed? Obviously, the faster they get the passenger to the final destination, the better, right? Imagine two airliners, both charging the same, but one gets to your destination 2 hours earlier. Which one would you prefer? The one reasonable explanation is, every airlines are in cahoot when they fly at particular speed and particular route. And as they differ so much, each pilot is given a speed list to ensure they follow the guideline. Actually, let's program that on the aircraft onboard computer instead. Sure. Let's look at your JetStream, shall we? Obviously, unlike our JetStream image, you guys don't seem to have a standard. I found 3 different ones to look at. First one, I have no idea what I'm looking at. Assuming standard, I guess red is stronger than green. Okay. Well, leg 1 seems to cut across all the stream rather than going with the flow. Same with leg 2. Leg 3 is the only one with the flow, which means one of the trip would be shorter. But do remember the return voyage. I don't even know what to say about the other 2. Same, I guess. The moment your return flight doesn't support your original conclusion of JetStream to help you with the inbound flight, well, you're really stuck. Final TLDR? To me, the whole video seems like a Strawman argument. Prove a point, then say all the Globers are making that claim, and then demolish it even further. Yep, meets the definition. Well, that will be all for this video. Thank you for watching. If you have enjoyed this content, can I please ask you to like, comment, and even subscribe to make sure you get to see more contents and also help this small channel grow. Have a safe day signing off.